Good day, YouTube community. My name is Ricky C. Layderos. I am from Camarines Sur Polytechnic Colleges. So we are a group of programmers. We made this program. This is an application of abstract data structure, a stack data structure for data structures and algorithms. So the overall function of this program is that this program will ask the user to enter any sort of integers he or she want to enter in each stack. So to properly explain the fundamentals, the overall fundamentals of this program, I will run this code. So now, upon running the application, it will display that the program will ask the user to enter elements for stack 1. So it's any sort of elements you want to insert. So for example, I will insert a number, a sort of integers 1, 1, 1, 2, and 3. Press enter. So the program will ask you again to enter elements for another stack, for stack 2, inserting 2, 3, and 4. So press enter. Again, the program will ask you to enter elements again for stack 3. For example, we will insert 1, 4, 1, and 1. Press enter. After entering all the elements in each stack, the program will display that the stack 1 has total height of 8, stack 2 has a total height of 9, stack 3 has a total height of 7. So how to know why the program display these heights? So to display the heights, the program will just calculate all the elements you entered in each stack. So we all know that in stack 1, it is 8 because the elements in stack 1, 1, 1, 1, 2, 3, the sum of this number is equivalent to 8. Same with stack 2 and stack 3. So in stack 2, it's 9 because 2 plus 3 is 5 plus 4, 9. And same goes around with stack 3 with an element of 1, 4, 1, 1. So summing up all these elements, we will have a total height of 7. So the all height are now equal to 5. So how this happened? It's all because abstract stack data structure is now being implemented. I will display or I will explain all of it with my PowerPoint presentation. So it is all because of pop, or in a linked list data structure, pop is like deleting an element. This is the presentation and explanation of the program we made. Previously, we enter elements in stack 1, stack 2, and stack 3. So in stack 1, we enter 1, 1, 1, 2, and 3. In stack 2, we enter 2, 3, 4. In stack 3, we enter 1, 4, 1, 1. So after that, we all know that the program displayed stack 1 total height is 8, stack 2 total height is 9, stack 3 total height is 7 because to get the total height, we add 1 plus 1 plus 1 plus 2 plus 3, which is the sum of these elements is equivalent to 8. Same with stack 2 and stack 3. Their total height is just the sum of each elements in each stack. The reason why previously it equals to 5 because the program has this statement in our code wherein this. So if stack 1 is greater than stack 2 or stack 3, we will pop the stack 1. Okay, so if stack 2 naman is greater than stack 1 and stack 3, we will pop stack 2. And lastly, if stack 3 is greater than stack 1 and stack 2, we will pop stack 3. So this is the implementation for that. So we all know that stack 2 is greater than stack 1 and stack 3. So we will pop stack 2. So upon popping stack 2, we will implement or apply the last in first out, or mostly known as LIFO method in this scenario. So we are now popping 4 here. Since 4 is the last in this stack, ibig sabihin kung sino yung pinakahuli mong ipinatong or inilagay sa isang stack, siya rin din yung unang tatanggalin or will be removed in these stacks of numbers. So we will pop stack 2 here. So number 4 will be removed. After popping the stack 2, we have now the updated total height of stack 2, which is 5 because the left elements in stack 2 is 2 plus 3. If we add this, we will have 5. So after that, we all know now that stack 1 is greater than stack 2 and 3. So we will now pop stack 1. So applying again the LIFO, number 3 will be deleted here. So popping the element 3. So upon popping the element 3, we are now have an updated total height of stack 1, which is 5. So stack 1 and stack 2 is now equivalent to each other. But stack 3 total height is still greater than stack 1 and stack 2. So what we have to do now is, of course, to pop stack 3 because stack 3 nga is greater than stack 1 and stack 2. So pop stack 3. So applying again the LIFO, 1 will be deleted here. So after popping stack 3, we will now have the updated total height of stack 3, which is 6. But since stack 3 is still greater than 1 and 2, we will still pop stack 3. So we will pop the number 1 here. After popping, we will now have an updated total height of stack 3. Since we now have an equal total heights of each stack, so the program will display all stacks are equal at height 5. So kung mapapansin nyo, the program will display stack 1 is 2, 1, 1, 1, stack 2, 3, 2, stack 3 is 4, 1. So this is not similar to the previous number you answered. It is because the fundamentals of abstract stack data structure is to reversely answer the number in the last. So number 2 will be transferred here. Same with 1, same with this, and we will now have the updated stack 1 list of 2, 1, 1, 1. Same application with stack 2. 2, 3 will now 3, 2, and in stack 3, 1, 4 will now be 4, 1. After that justifying, we all know that it's equal to 5. The program will ask you if you want to continue, or if you will press Y, it means you will continue, and if you press N, it means you want to exit the program. So for this situation, I will continue so that I can show more examples for this program. So for example, we want to insert again or enter elements for stack 1. For example, numbers of 3, 2, 1, 4, 3. And for stack 2, 2, 1, 1, 4, 2. And then for elements for stack 3, 1, 3, 2, 1, and 1. Press enter here. The program will display that stack 1 total height is 13, stack 2 total height is 10, stack 3 total height is 8. The program display the else statement, stack heights will never be equal because maybe the condition is not met. So if we will apply the logic of the program where it will be equal or not, we will manually solve this problem. So since that stack 1 is greater than stack 2 and stack 3, we will pop stack 1. So we will pop number 3 here. We will pop number 3. After popping number 3, we will now have an updated total height of stack 1, which is 10. We all know now that stack 1 has a total height of 10, stack 2 has a total height of 10, stack 3 has a total height of 8. So with this, since stack 1 and stack 2 is greater than stack 3, we will pop stack 1. We will pop stack 1. And so popping stack 1, we will now have an updated list of 6. An updated total height of stack 1 will be 6. For stack 2 will be 8. Updating all the total heights of each stack, we now know that stack 2 and stack 3 is greater than stack 1. So now, since stack 2 and stack 3 is greater than stack 1, we will pop stack 2 and stack 3. So popping number 4 here and popping 1 here. So after popping stack 2 and stack 3, we will now have an updated total height of stack 2, which is 4, and for stack 3, which is 7. So since that stack 3 is greater than stack 2 and stack 1, applying again the same application, popping stack 3 here, we will pop number 1. So updating the total height of stack 3. So since that stack 1 and stack 3 is greater than stack 2, we will pop stack 1 and stack 3. So stack 1 will now have an updated total height of 5, and stack 3 a total height of 4. Now, since stack 1 is greater than stack 2 and stack 3, we will pop stack 1. So we will deleting number 2 here. Now we will have an updated total height of stack 1, which is 3. And then upon observing, we all know that stack 2 and stack 3 is greater than stack 1. So we will pop stack 2 and stack 3. Popping element 3 here. So we will have now the updated total height of stack 2, which is 3, and stack 3, which is 1. So since stack 1 and stack 2 is greater than stack 3, we will pop stack 1 and stack 2. So we will pop 3 here, and we will pop 1 here for stack 2. So updating all the elements, we now know that total heights of 1 will be equal to 0. It means it's empty. So the program will stop running, and then will display that stack heights will never be equal, because upon applying the conditional statement of the program, the elements you entered in each stack 1, stack 2, and stack 3 will never be equal once we will apply the abstract data structure of this program. So entering again another examples. For example, we will input in stack 2, 4, 6, 8 for stack 1. So for elements for stack 2, for example, 6, 6, and 2. And for stack 3, 3, 3, 6, and 9. So press enter. So all height are now equal to 12. After entering all those elements, all height are now equal to 12, because since stack 1 is greater than stack 2 and stack 3, we will pop stack 1, and then after updating, we will see who is the greatest, and we will pop again that stack. And until that, the program will justify that heights are now equal to 12. And then after that, the elements you insert for each stack will be reversely updated and inserted in stack 1. It's, for example, the 2, 4, 6 will be 6, 4, 2 in new stack, same with stack 2 and stack 3. So entering another examples by pressing Y, which means you want to continue. So another, if you want to enter a string number of 1, 4, 2, 2, 3, for stack 2, 2, 1, 2, 1, 3, 1, and 4. For stack 3, 5, 2, and 1, and 1. Press enter here. So applying again the method that I did previously, so applying again the method, we all know that stack 1 is greater than stack 3 and stack 2. So what we have to do again, pop stack 1. So we will pop number 3 here. So we will now have the updated total height for stack 1, which is when we add 1 plus 4, 5, plus 2, 7, plus 2, 9. So now we have the updated total height of each stack. So as of now, we all know that stack 2 is greater than stack 1 and stack 3 by having the 11 as total height. We will be pop stack 2. So applying the LIFO, number 4 will be popped here. After popping stack 2, we will now have the updated list of 2 plus 1 plus 3 plus 1, which will be equivalent to 7. Since we have stack 1 and stack 3 are greater than stack 2, we will pop stack 1 and stack 3. So popping stack 1 here, we will remove number 2. and pop number 1. So updating the total height of each stack. So stack 1 will now have a total height of 1 plus 4, 5 plus 2, 7. Same with stack 3, we will now have 5 plus 2, 7 plus 1, 8. So since that stack 3 is still greater than stack 2 and stack 1, we will pop stack 3 again. So we will pop 1 here. So upon popping stack 3, we will have the updated total height for stack 3, which is 5 plus 2, 7. So now, since stack 1, stack 2, and stack 3 is now equal to each other, the program will display that all height are now equal to 7. Last example for the program. For example, we want to enter the elements of 1, 2, 3, 4, 5, and 7, 8, 9, 1. And for stack 3, 1, 4, 6, and 8. So the program will display that the stack heights will never be equal because, okay, let's say that yes, stack 2 is greater than stack 1 and stack 3. If we pop stack 2, the process will be popping the stack 1, maybe the stack 2, maybe the stack 3, but will never meet the condition where the stack 1, stack 2, and stack 3 total heights should be equal to each other. So since the program detected that they will never be equal, so the program will display that stack heights will never be equal. So that's the end of the examples for this program. So for the exit prompt, if you want to exit and you don't want to try and continue the program, just insert letter N, maybe a small or big letter N, it's up to you. And then the program will display thank you as a message, meaning that the program is ended by yours.